Okay, so ready to dive into AI. That seems like it's straight out of science fiction.
Let's do it.
Today, we're tackling Deep Speech 2.
Really fascinating system.
It's a speech recognition system that's, well, it's so advanced, it can understand you, even if you're in a noisy room, you have an accent, or even if you're speaking a completely different language.
It's pretty wild what it can do.
Yeah, and to really get into it, we've got excerpts from the research paper. It's called Deep Speech 2, End-to-End Speech Recognition in English and Mandarin.
And it really is a game changer. Like this system, it marks a huge shift from all those, those clunky systems that we used to use. Deep Speech 2, it actually replaces all those hand-built systems with just one model, like a single elegant model that learns all on its own, which is incredible.
It's almost like teaching a computer to learn a language the way that we do, right?
Yeah.
Like you feed it information and then it just figures things out.
Precisely. Yeah, you got it. So the key here is this. It's end-to-end deep learning. Okay. And Deep Speech 2 uses something called a recurrent neural network. RNN, exactly. And it's specifically designed to process what we call sequential data, like speech.
RNNs, neural networks. This is already sounding pretty complex.
It is. It is. But like at its core, just imagine like this. Okay. Picture an AI, and it's listening to a melody. So it remembers each note, right? And it uses that memory to anticipate the next note in the sequence.
Okay.
And that's kind of similar to how an RNN processes speech. It's remembering those sound patterns and predicting what comes next.
I like that analogy. Yeah, that makes a lot of sense. So it's basically like it's learning directly from the data itself, right? Not from like some pre-programmed rules of language or anything like that.
You got it, yeah. It's discovering those rules on its own directly from the data. And here's the really cool part. Deep Speech 2 processes this information crazy fast. We're talking 7 times faster than the previous version.
Wow.
Thanks to something called high-performance computing, or HPC. Think supercomputers tackling this challenge head-on.
7 times faster. That's unbelievable. I mean, what does that speed even translate to in a practical sense?
So in a practical sense, it means faster experiments, more efficient learning, and ultimately it means an accuracy that rivals, and in some cases even surpasses, human-level performance.
Okay, now that's just impressive. So we're talking about AI that's not just keeping up with human transcribers, but like actually exceeding them.
You got it. And this isn't just in some controlled lab setting either. They really put this thing through the ringer. They tested it on all sorts of challenging data sets, accented speech, they used VoxForge, and then noisy environments. They used the Shichima challenge, and the results are amazing.
So it seems like they built this system to handle like real-world situations right out of the gate. Okay, it's clear that Deep Speech 2 is doing something incredible, but how did they actually build this thing?
Well, to understand that, we've got to take a closer look at what's happening under the hood. So one of the things that makes the system so powerful is the depth of the networks.
Yeah, the neural networks.
Yeah.
We're using like networks with up to 11 layers.
It's a lot, yeah.
Which is just crazy. Each one, like adding more processing power to the system.
Yeah, it's like they built a super brain, but specifically for understanding speech.
Exactly.
Which is really wild, and training these massive networks, it's not easy, let me tell you.
Yeah, that's where batch normalization comes in, right?
Batch norm.
Batch norm, yeah. Saw that in the paper.
Yeah, so batch norm is like, imagine you have an orchestra, right?
Okay.
Batch norm is like the conductor, making sure all the instruments are in sync.
Got it.
Right, so all the parts of the neural network, they're all learning at a similar pace. Nothing gets out of whack. And that helps streamline the training process considerably.
So it's all about balance.
Yeah.
And speaking of, optimizing the learning process, Deep Speech 2 also incorporates something called sortigrad, right?
Right. Yeah, sortigrad. So that's a cool technique because instead of throwing the most complex challenges at the system all at once, they start with, smaller, simpler bits of speech.
Okay.
And then gradually increase the difficulty as the system learns. So it's kind of like, you got to learn to walk before you can run a marathon.
Makes sense, yeah.
You got to crawl before you walk.
Exactly. Yeah, it's interesting how these training methods like really do mirror how humans learn.
Yeah, it's true, yeah.
In a lot of ways.
Yeah, it's like they're trying to mimic the human brain.
But let's talk about these GRUs.
Okay.
Gated recurrent unit.
Yeah.
If RNNs are like the brains or GRUs, like the hippocampus, the memory center.
Yeah, that's a great way to think about it. Yeah. So just like our hippocampus helps us form those long-term memories, GRUs, they excel at remembering these long sequences of information.
Which is critical.
Critical.
For understanding language.
Yeah, absolutely. Because the meaning of a word, it often depends on the words that came before it, right?
They're connected.
It's all connected. You need that context.
Yeah.
And you need to remember the beginning of a sentence to really fully grasp the meaning at the end.
Right.
And all of this, the RNNs, the GRUs, these clever training methods, none of it would even be possible without a massive, massive amount of data.
Oh, yeah.
This
How did they
thing,
flee?
deep speech too, it's a data-hungry beast.
When you say massive, like, how much data are we actually talking here?
Like, hold on to your hat. 11,940 hours of English speech.
Oh, my gosh.
And 9,400 hours of Mandarin.
That's years of continuous audio.
Years, it's unbelievable.
That's mind-boggling.
It's a lot of data.
But it's not just about the quantity.
No.
Right? The quality of the data has to be top-notch, too.
Absolutely. You're 100% right. The quality is key. And they were very, very meticulous about cleaning up the data, removing any errors, organizing it in a way that just makes it easier for the system to learn. And get this, they even added noise to the data.
Wait, they added noise. Why would you add noise?
So it seems counterintuitive, right? But they added noise to make it more realistic.
Okay.
Because think about it, like in the real world, we're not always speaking in these perfectly quiet environments, right?
Right.
So by training Deep Speech 2 on data that includes, background noise,
Yeah.
they ensure that it can actually handle the unpredictable sounds of the real world.
Like a crowded cafe.
Crowded cafe, busy street, you name it.
Exactly.
They're trying to mimic that chaos.
So they're basically trying to mimic the chaos of real-life conversations
Right.
to make Deep Speech 2 more robust.
Precisely. It's all about preparing it for that wild world outside of the lab.
Outside the lab, exactly.
But speaking of the real world, how does Deep Speech 2 actually perform when you put it up against the gold standard human transcribers?
Right, because that is the million-dollar question.
It is, yeah.
We've talked about all these technical details and the architecture and the training data and everything.
Emphasis on-
But ultimately, it really comes down to how well it performs in these real-world scenarios.
Does it actually work?
So it really does all come down to that, right?
Yeah.
How did Deep Speech 2 actually stack up against those human transcribers?
Yeah.
Did all that work, all that data, actually pay off?
Well, they put it through the ringer. I mean, they ran a whole gauntlet of tests. Everything from those challenging data sets that we were talking about.
Yeah.
With all the noise and the accents and everything to the more standard benchmarks, like that Wall Street Journal corpus, which is known for its really clear, carefully spoken audio.
Kind of like how we're talking now, hopefully.
Exactly, yeah. And, on those cleaner data sets, Deep Speech 2 was right up there with human transcribers. In some cases, it actually performed even better based on certain metrics.
Wow. So in those ideal conditions, it's not even just keeping up, it's exceeding human capabilities.
Yeah, it's pretty amazing to see.
That's pretty incredible. What about those more, challenging tests, like those real-world scenarios where you got all that noise and those heavy accents? How'd it do on those?
Well, that's where it gets really interesting. So they found that on the accented speech, Deep Speech 2 really closed the gap significantly with human performance, especially compared to the earlier versions. So clearly that, that huge, more diverse training data set, it's really paying off.
Yeah, it's like learning to generalize better, handle all those variations in human speech.
Exactly, yeah.
Which makes a lot of sense. But what about the noise? I feel like that's the thing that really trips up, most speech recognition systems.
You're absolutely right. Noise is a tough one. It's a really hard problem to solve. And, Deep Speech 2, it does show a lot of improvement in handling that noise compared to the older systems.
Right.
But it's still, it's still lagging a bit behind human performance in those, really, really chaotic environments.
Which makes sense because, our brains are they're amazingly good at filtering out all that irrelevant noise and just focusing on what's important, in a conversation.
Exactly. And that's something that researchers are really working on now, teaching AI to be more, selective, like we are, with the information it processes. It's about trying to really, mimic that human ability to just hone in on the important stuff and block out the rest, which is really hard to do.
Yeah, for sure. So Deep Speech 2, it's a remarkable achievement. That's clear. But it's obviously not, the finish line. So where do we go from here? What's next for Deep Speech 2?
Well, that's the exciting part. Now that they've built this like really powerful engine, right? The focus really shifts to like, how do we get this out into the world?
Yeah.
And they've actually done some really fascinating things, made some interesting choices to make that happen. Well, a big one is speed and efficiency. Those are like top priorities now. So they've developed things like batch dispatch, which basically lets the system like process multiple requests at the same time, simultaneously.
So no more like waiting around for the system to like catch up or anything. You can handle stuff in real time.
Exactly, exactly. And they've even found ways to like make the model itself smaller, leaner, faster by using something called half precision floating point arithmetic.
Half precision. I mean, honestly, that just sounds like you're like sacrificing accuracy for speed, though.
You would think so, right? But, and this is what's amazing, it doesn't actually seem to impact the accuracy at all.
Wow.
It just lets them process information faster, use less memory, which is really important when you're thinking about like deploying this on a larger scale.
So it's all about like working smarter, not harder, right?
Exactly.
Finding those elegant solutions to make these really complex systems like work seamlessly in the real world.
Precisely. And that's what makes this like such a pivotal moment, I think. Deep Speech 2 isn't just some like theoretical exercise. It's like a glimpse into the future where technology can understand us, like really understand us and respond to us in ways that, we never thought possible before.
Yeah, it really makes you wonder where we're going to be in 5 years, 10 years. Like, will we even need human transcribers anymore?
That's the question, isn't it? It's a big one, and it's something we're going to have to grapple with as all this technology just keeps advancing. But, one thing is for sure, Deep Speech 2 has definitely raised the bar for everybody. It's pushing those boundaries of what we thought was possible in speech recognition.
Absolutely. It's definitely an exciting time to be following AI. And Deep Speech 2 is a perfect example of just how rapidly this field is advancing. So you've taken a deep dive into Deep Speech 2, a system that's really pushing the boundaries of what we thought was possible with speech recognition. We've gone from its innovative architecture to its massive training data sets. And it's clear that Deep Speech 2 is really blurring those lines between human and AI capabilities. What will they think of next?